Welcome back to The Explainer. Today, we're going to demystify what is honestly one of the most massive technological leaps of our entire lifetime. We're tracing this fascinating evolutionary jump from traditional, super rigid machine learning all the way to the dynamic, incredibly flexible world of large language models. If you've ever found yourself wondering how artificial intelligence went from being this incredibly narrow, single-purpose tool to a versatile assistant seemingly overnight, well, you are definitely in the right place.
Okay, let's dive right into this. Here's our roadmap for today's explainer. We'll start with traditional machine learning, then check out supervised versus unsupervised data, hit the generative AI breakthrough, look inside few-shot learning, and finally, wrap up with controlling AI system prompts. All right, let's start right at the beginning. Section 1, traditional machine learning, the old paradigm. To truly appreciate the massive leap AI has made, we really first have to ground ourselves in how artificial intelligence used to be built from the ground up. Take a look at Model A here. To build this, developers had to gather data on a very, very specific problem. Let's say predicting house prices. They built this single model, Model A, purely to predict or classify based on that exact real estate data. Now, contrast that with Model B. If you suddenly decided you wanted an AI to deal with mapping or spatial routing, yeah, Model A was completely useless to you. You had to go out, gather entirely new data, and build Model B entirely from scratch. You can really think of these like highly specialized physical tools. A hammer is great for a nail, but it's totally useless if you need a screwdriver. So the absolutely crucial point here is simply one model equals one task. Traditional machine learning meant you trained on a specific task, you absolutely needed data for that specific task, and once it was trained, well, the model was useful only for that one thing. This framework was undeniably powerful for what it did, but it was incredibly rigid. There was absolutely no generalized problem-solving happening here.
Which brings us nicely to Section 2, supervised versus unsupervised data. And this brilliantly illustrates the fuel behind those rigid models. Data and modeling essentially came in two distinct flavors, and there's a stark visual difference between them. On the left, we have labeled, or supervised data. Notice those graphs for classification and regression. You can literally see clear lines separating the crosses from the circles, or a trend line plotting a very clear trajectory. The model is given structured input-output pairs to learn exact relationships. Now look over at the right side, unlabeled, or unsupervised data. Look at those clusters. Here, the data doesn't come with neat little labels, so it can't find those strict relationships. But it can be used to group similar data points together based on hidden patterns. But here is the real kicker. Whether you were feeding the machine neatly labeled supervised data or clustered unsupervised data, both flavors still equal the exact same thing. You are still just building rigid, highly specialized tools. Which honestly begs a massive question. What if a model didn't need to be rebuilt from scratch every single time the task changed? That exact question leads us right into Section 3, the generative AI breakthrough. This is it. This is where the old paradigm shatters and the pace of innovation just completely explodes. We are finally moving away from those single-task robots. In fact, the source material explicitly calls this the breakthrough that changed the world. It's a huge statement for sure, but it perfectly captures this mind-bending shift from models that only know how to price houses to models that can suddenly write poetry, debug software code, and translate languages, all within the exact same framework. Let's crack open the hood and see how in Section 4, inside few-shot learning. Now, what's really interesting about this is how this new Swiss Army knife of AI actually operates. It all comes down to the mechanics of in-context learning. Instead of requiring thousands of highly specific, painstakingly labeled examples to be hardwired into a completely new model, few-shot learning does something completely different. A transformer model uses its vast set of parameters and what are called attention matrices, so when you hand it a prompt, it focuses intensely on the input you just gave it, and it attempts to actually understand what the task is right then and there. It's literally adapting on the fly based entirely on the context you provide. To really cement this idea, just look at the stark contrast between this incredibly dynamic in-context learning and the old method of fine-tuning. Remember those graphs we just looked at? Fine-tuning requires those rigid, structured input-output pairs. The model is simply memorizing a static relationship, a specific path. But in context learning, it uses those attention matrices to flexibly adapt to entirely new tasks long after the initial training is completely finished. It is exactly this unprecedented flexibility, this ability to adapt on the fly, that formed an entirely new industry, generative AI. Which finally brings us to our last stop, Section 5, Controlling AI, System Prompts. Let's move to and see how this all builds together. Because having this incredibly powerful, flexible engine that learns in context is amazing, but it's kind of completely useless without a steering wheel, right? We need a way to guide this generalized intelligence. And that steering wheel is your system prompt, basically your foundational instruction manual for the AI. It relies on three main pillars. First up is tone. You can instruct the AI to be highly formal, super casual, or follow very specific ethical guidelines, which completely changes its personality. Second is context. You're basically setting the scene here. For instance, your prompt might tell the AI it's role-playing as a customer service rep or maybe a high school math tutor. And third is consistency. A truly great system prompt ensures that the AI's responses stay remarkably consistent throughout the whole interaction, adhering strictly to the predefined rules you set up in steps 1 and 2. Honestly, it's how you keep this amazingly flexible model from just wandering completely off topic. So we have journeyed all the way from the rigid, one model to one task days of traditional machine learning straight into the flexible, in-context learning of modern large language models. You now understand that you aren't just querying some static database. You're feeding context into a vast network of attention matrices that are adapting dynamically to your specific needs. So I want to leave you with this thought. Knowing how the engine actually works and how tone, context, and consistency steer the whole vehicle, how are you going to write your next prompt? Thanks so much for joining me on this explainer, and keep learning.